Hello, everyone. Today we are starting 9.4, which is arithmetic sequences. So, a sequence is a set of numbers in a specific order. If the difference between successive terms or terms in order is constant, then the sequence is called an arithmetic sequence. So, an arithmetic sequence is a numerical pattern that increases or decreases at a constant rate, called the common difference. So let's look at example one. So our numbers are 1, 3, 5, 7, 9, 11. So when I go from 1 to 3, I did 1 plus 2. And then my next number is 5. So I did 3, which was 1 plus 2 plus another 2. Then 7, added another 2. And if I think of this as a chart where n is the term number, it would be 1. My term numbers just always increase by 1. So 1, 2, 3, 4. So my second term has 1 2. My third term has 2 2s. My fourth term has 3 2s. So it's always the generic equation is always a sub n. N is any number, is the first term, a sub 1. So this is our first term, plus d, which is our difference, our common difference, times n minus 1. And it's always n minus 1 because there's one less 2 than that term. So if possible, so we're justifying if this was an arithmetic, and yes, because you add 2 each time. And this generic equation right here, you need to memorize. It's the same thing as what's up here. I put the d in front, they put the d in back. Doesn't matter. So if write an equation for the nth term, so here when I'm going from 12 to 15, I add 3. So d is 3. And so I use that generic form and I simplify and I get the generic term. So let's do examples. So determine whether each sequence is arithmetic, yes or no, or explain. So here I go from 1 to 5, I add 4. 5 to 9, I added 4. 9 to 13, added 4. 13 and 17, added 4. So yes, and d equals 4. So I want you to pause and try number 2 and 3. So number 2 is yes, because to go from 8 to 4, I subtract 4. 4 to 0, I subtracted 4. 0 to negative 4, I subtracted 4. Negative 4 to negative 8, I subtracted 4. And d equals negative 4. 3, here I add 2, then I add 6. So it's no common difference. So number 4, they want me to find the next 3 terms in the arithmetic sequence. So they're telling me it's an arithmetic sequence, which means I just need to find the common difference. So here, to go from 9 to 13, I'm adding 4. So to find the next 3 terms, I do 25 plus 4, which is 29, then 29 plus 4, which is 33, and 33 plus 4, which is 37. So I want you to pause and find the next 3 terms in 5 and 6. So number 5, here I'm subtracting 4 each time, so d equals negative 4. So do negative 12 minus 4, that's negative 16. Negative 16 minus 4 is negative 20. Negative 20 minus 4 is negative 24. Number 6, Each time here, I'm adding 6. So I do 47 plus 6, which is 53. 53 plus 6 is 59. And 59 plus 6 is 65. Now here, I want to write the equation for the nth term. So this is using that generic equation that you need to memorize. A sub n equals a sub 1 plus d parentheses n minus 1. So when I look at number 7, a sub 1 is 1. It's always the first term. And then I need to find d. So d is what I'm adding. So each time I'm adding 2. So d is 2. So that means a sub n equals 1 plus 2 parentheses n minus 1. And now I simplify. So I'm going to distribute that 2. So I get plus 2n minus 2. And then combine like terms, the 1 and the negative 2. So a sub n equals 2n minus 1. Pause and do 8 and 9. So number 8, a sub 1 equals negative 1. And my d is subtracting 3, so negative 3. So I do a sub n equals a sub 1 plus d parentheses n minus 1. I substitute in a sub 1 is negative 1 minus 3 parentheses n minus 1. I simplify by distributing. So I get negative 1 minus 3n plus 3. Combine like terms, and a sub n equals negative 3n plus 2. Number 9, a sub 1 is negative 4. My d is negative 5 because I'm subtracting 5 each time. So a sub n equals a sub 1 plus d parentheses n minus 1. I substitute in. So it's negative 4 minus 5 parentheses n minus 1. And then I simplify. Now, one thing I want to discuss before we move on is what is the point of writing this sequence or writing the equation? If I look at number 9, we found in the previous problems, we found the next 3 terms. The point of writing the equation is, what if I wanted the 100th term? If I want the 100th term for 9, that means n equals 100. So if I continue this pattern out to 100 numbers, my value would be a sub 100, which is negative 5 times 100 plus 1. So it would be negative 499. So that's the point of writing these equations. So that's the end of our video for today. If you have any questions, please ask tomorrow in class.